I covered the basics of our central limit theorem simulation in the previous video. In this video now, I'm going to just briefly discuss some additional ideas for classroom experiments. In our experience, these kinds of ideas will work either as a teacher-led demonstration or even as an independent activity. And our website provides some additional supportive instructor materials like worksheets or problem set questions to help you using these either way. So the first activity I might suggest using with students is to just ask them to try out all the different distribution shapes that we offer. There's 5 here. 3 of these are relatively funny looking. And just ask them, do they still see a bell-shaped curve for the distribution of the sample means? And if they do, how large of a sample size did they need to use for each of these? Is there any difference that they could see? Do they need to increase the number of replications? So that's an easy one to demonstrate. And of course, the whole idea of the central limit theorem is that no matter which ones of these they choose, they will see that beautiful bell-shaped curve, or at least that beautiful bell-shaped distribution for those sample means. What I'm going to walk you through now is, I think, my favorite activity you can do with students, which is to ask the question, how large does the sample size need to be for us to see the distribution of sample means start to appear bell-shaped? And just like before, I'm going to choose a really funky looking mystery distribution to try this out. And I'm going to just skip all the way down to the simulation part. And what we're going to do is begin with samples of size 1. And we'll start with 1,000 replications. Before you do this, you should ask students, what should this distribution look like? So if we're drawing samples of just one observation, then the sample mean is just going to be the value of that observation. Since we're drawing right from the population, then this should look just like the population above. So we should see a weird two-humped kind of distribution. Let's verify that by clicking the Run button. So good, that has approximately that kind of bimodal appearance of the population distribution of alien heights. Let's now proceed then by making this really a sample. Let's choose random samples of size 2 from the population up top, and again run 1,000 replications and see what this starts to look like. So isn't that interesting? It's still relatively funny looking. It doesn't look like a bell yet, but you can already start to see some of that central tendency. And that's created by the fact that even with a sample of size 2, the sample mean is taking an average of those two values, and then hence that sample mean value is going to start to seek the middle. Let's now increase the sample size to 3 and run it again. Ooh, that's starting to look increasingly more like a bell-shaped distribution. Let's increase it up to 5. You can really see the central tendency now. And if you click the Convert to Standard Normal button as you do each of these, you can really start to see that bell shape emerge. I think this is really a magical demonstration of the central limit theorem and really shows you that what the central limit theorem rests upon is the definition of the sample mean as an average of the underlying observations in that sample.